This is a part 2 of I/O port of a microcontroller. All general-purpose I/O can be either input or output. You have to set it up before you use it. There are 3 addresses you have to deal with. These addresses are represented by labels. For example, for port A, they are DDR-A, port A, and pin A. So the label listed here, X can be A, B, C, D, E, and F. The same. DDRX is used to control whether the external pin is connected to port X or pin X. The other 2 labels are associated with the other 2 terminals in this diagram. DDRX is data direction register that defines the I/O as input or output. The value 0 defines the pin as input, which as you can see from this diagram, 0 forces the switch to connect to pin X. So that we can read the external signal at the pin from pin X. So that you can see pin X is for us to read the data appear in the external pin. When we have defined the pin as input, then we can use port X to enable the pull-up resistor or disable it. So the value 0 would disable the pull-up and 1 enable the pull-up resistor. The value 0 written to DDRX defines the pins as input, and the value 1 will define the pin as output. The value 1 in DDRX turns the switch onto the upper position so that the external pin now is connected to the internal terminal, port X. So that when we write the data to port X, and the data will be output to the external pin. Now let's look at how to use GCC to set up the I/O ports and use them for input and output. How to use port A for output. To output to the port, we need to define the data direction as output, which means we need to write 1 to all bits in DDR-A. We have done that before in our first C program. After we have defined the port as output, then we output data to it. Say we output the value held by the variable X to port I using this statement. To use port B as input port, we need to do 2 things. Define the data direction and then input data from the port. To define the port as input, we write 0 to all bits in DDR-B. After we have defined the data direction as input, there are options whether to enable or disable pull-up resistors. We disable them by writing 0 to all bits in port B, or disable them by writing in port B. By default, all ports are input ports with pull-up resistors disabled after parallel up. Then we can read the port by using a statement like x equal to pin, which means to get the value from the right-hand side, which is pin B, and then assign the value to the variable in the left-hand side, x. Here is some example using push button or LED as a simple input and output device. For push button, you will connect the push button this way, one terminal push button to ground, the other terminal to the input pin of the microcontroller, and then you need to enable the pull-up resistor so that when the push button closes, you got pulled down to 0, so the result will be 0. And with the push button open, and the value here will be pulled up by the pull-up resistor, so the value will be 1. To achieve that, here's the C language statement. So the first statement defines the port as the input, and then enable pull-up resistor, and then you can get the input from pin C and assign to a variable x. For the LED, we can use logic 1 to turn on, which is now you connect the LED through a current limit resistor to the output pin. So in C language statement, define the port as output using FF, and then output the value 1 to turn on the LED. You can also use logic 0 to turn on the LED. In that case, you need to connect your LED in this way. VCC through a current limit resistor, and then LED, then connect to the output pin of the microcontroller. Now, your GCC code statement will be like this, using this statement to define the port as output, FF, and then you need to output 0 to turn it on.